In this session, we'll be taking a look at effective interest rates. Now, effective interest rates are a critical part of the whole financial mathematics topic, and it ties into everything we've done so far. So this is an important topic and is something that people often struggle with. So it's really important that we understand the underlying concepts behind it in order to apply it, because it's really the cornerstone of all these topics. So if we don't get this right, you won't get the final answer right for your financial mathematics. So in this session, we'll be looking at sort of the theory behind effective interest rates, so why we need them. We'll be looking at the formula, and then we're just going to take a look at some examples. So firstly, just having a look at the theory. So as I've discussed before, when using the annuity formula, the rate must be compounded in the same time unit as cash flows. So if the cash flows are occurring per month, you need a rate that's compounded monthly. And this is where the issue comes. So when you are given a rate that is not compounded in the same time unit as the cash flows, we have to convert this, and we do that by using the effective interest rate formula. So if you are given cash flows per month, but you're given an interest rate compounded annually, you need to use the effective interest rate formula to convert this to a compounded monthly rate. So the formula is simply this. So we've got the effective rate is equal to 1 plus, and this is going to be the rate given. So when I was talking about 10% per annum compounded annually, that will be the annum. Now, compounded period of rate given. So if it was compounded annually, this would be 1. If you're given a rate that's compounded monthly, it'd be 12. So this is always going to be a per annum rate, but compounded in whatever you're given. So 10% per annum compounded annually, 10% per annum compounded monthly. It doesn't matter, it's always per annum. And this will be on how it's compounded. So as I said, per annum compounded annually, M is 1. Per annum compounded monthly, M is 12. So that's the same up here, same M. And N is the compound period you want. So if your cash flows are every quarter, you want a quarterly rate. So N is going to be 0.25. If your cash flows are every month, you want a monthly rate. So N is going to be 1 on 12. If your cash flows are every year, you're going to want a compounded yearly rate. So N is going to be 1. So that's your formula there. So as long as you remember rate given, M, and rate you want, N, you should be right. So now we're just going to take a look at some examples of certain things that you could get. So your first example is if you've got $100 invested every year for 5 years at 10% per annum compounded annually. So here we've got cash flows occurring at the end of each year. So we need our rate to be compounded annually. In this case it is, so we don't have to use the effective interest rate formula. So we've got 10%, that's fine, per annum, annually, and it's every year. We're all good. We've then got T is 5 because it's 5 years, and A is 100. So putting that straight into the present value formula, and we can figure out our present value. So our second example is $100 invested every year for 5 years at 10% per annum compounded quarterly. So we can see here that it's every year, but we've got a compounded quarterly. So we're going to need to use the effective interest rate formula. So effective interest rate, we're given a rate compounded quarterly. So we've got 10% per annum, and we've got over 4 for quarterly. 4, and we want an annual interest rate, so it's going to be times by 1. So put that all in, and we get a rate of 10.38%. Now, what we need to note is that this is ready to go straight into the formula. So we've got 10.38%, 5 years, A equals 100, put it in, and we've got our answer. So the third example, $100 invested every 6 months for 3 years at 10% per annum compounded semi-annually. Okay, so compounded semi-annually, and we've got the cash flows occurring semi-annually, so we don't have to use the effective interest rate formula. So, but what we do need to do is, remember how I said R has to be in the same time units? Although it's compounded semi-annually, it's a per annum rate. It needs to be a per 6 month rate. So we just need to divide it by 2. So as long as it's compounded in the same rate, we don't have to use the effective interest rate, but we might have to divide it by the amount of sort of periods in that year. So if it was a per month sort of thing, so if it was 12% per annum compounded monthly, we'd divide by 12 to get 1% per annum per month. So R is 5%. Same as time. So although it's 3 years, we're going to have 6 cash flows because it's every 6 months. So T is 6 and A is 100. So putting that in, and we get the answer. Now in the last example, we've got $100 every 6 months for 3 years, but in this case we've got a compounded annually rate. So we're going to have to use the effective interest rate formula. So we've got 10% compounded annually, so the rate that we're given is 1 up here, and we want it every 6 months because that's when our cash flow occurs. So this is going to be 0.5. Put that in and it's 4.88%. Now remember I said this is ready to go straight into the formula. It's not a per annum rate, it's going to come out as a per 6 month rate. So we don't have to worry about dividing by 2 like the last thing. So that's all that it says here, it's ready to go straight into the formula. So, as I said, this is now 4.88% per 6 months. So that would normally be stated as 9.76%, so just times by 2, because it's normally stated as a per annum rate, but compounded however it is compounded. So putting it in the formula, we've got 4.88%. Remembering we still have to times the 3 by 2 because it's 3 years for every 6 months. So we've got 6 and A equals 100. And you've got your answer here. So that's it for effective interest rates. So this is really tied into the annuity topic. So we really have to think about, this is the sort of first step, is what is our interest rate, how is it compounded, and how do we have to manipulate this to get our R, our T and our A in order to put it into either straight off the annuity formula, or then use this in deferred annuities, annuity dues, perpetual annuities, anything like that.